The workshop is silent, save for the low hum of electronics. Erick stands before his workbench, the center of his world. Before him, the STM32MP257F DK Discovery Kit glows under the sharp LED lamps. To others, this might look like a mere hobbyist board, but Erick sees a high-precision industrial sentinel. Today, he isn't just building a gadget, he is creating a window into the atmosphere. He reaches for the BME-280 sensor. His movements are deliberate. With the soldering iron in hand, he attaches the leads to the 4-0 pin header. He knows that in meteorology, noise is the ultimate enemy of truth. Next, he moves to the mast, securing the anemometer. He checks the alignment of the reed switches over and over. They must be perfect. He connects the signal wires to the GPIO ports, specifically port D. Readying the hardware interrupts that will capture the heartbeat of the wind. Erick slides the entire assembly into a rugged, NEMA-rated IP67 enclosure. But a sealed box is not enough. He applies a specialized Cortex patch. This breathable membrane allows for pressure equalization, ensuring the barometer remains accurate while preventing moisture. It is a delicate balance of protection and accessibility, the hallmark of industrial-grade design. The hardware is now ready to face the storm. Erick boots the system, and the OpenST Linux terminal begins its rapid scroll. But the real magic happens in the background. He focuses on the Cortex-M33. Using the STM32 Qubit, he flashes the custom firmware. On the serial monitor, the M33 begins its tireless work. It captures raw pulses from the anemometer, calculating wind speed with microsecond precision that a standard processor could never achieve. This is the foundation, where raw signals are transformed into numbers. Now, the two worlds of the processor must communicate. He opens the RPM's G channel, watching data packets flow seamlessly. On the A35, he launches the primary C++ application. The 7-inch DSi touchscreen flickers to life, revealing a stunning dashboard. Using OpenGL ES, the system renders anti-aliased gauges. But the system does more than just display the present. Erick feeds the last 24 hours of historical data into the integrated NPU. The neural network processes the sequence, calculating trends, displaying a localized, short-term forecast. It is no longer just a sensor, it is an intelligent observer. The final step is connectivity. Erick configures the MQTT client. A green light blinks on the console, signaling a successful handshake. The data is now part of the global network. He performs one last check on the power management routine. He confirms the M33 core will keep the system in a deep, low-power sleep. Efficiency and performance are now perfectly synchronized. The station is live. It stands as a silent, powerful observer. Erick watches the screen one last time. He has succeeded in turning raw environmental chaos into precise data. The storm may come, but he is ready. The sentinel is watching.